But without further ado, I will introduce David Shattuck, and he will take you on the wild journey of blockchain to the blockening.
Cool, thanks, Katie. Well, hello, good morning, everyone. Thank you so much for being here. My name is David Shattuck, and the topic for our presentation today is blockchains. Again, so this is a talk that I have been thinking about for a while, and I'm super jazzed to be sharing it with you today. Before I kind of jump into the content, let me say a quick thank you to Smart Data. I appreciate you hosting these Lunch and Learns every month. I always look forward to them. And of course, a special thank you to Katie for doing all the legwork to organize things and kind of bring it all together. So let's do a quick introductory slide. My name again is David Shattuck. I'm a senior engineer and tech lead at Smart Data. I've been with the company for about 5.5 years. This is my email address, so please feel free to drop me a line. I'd love to hear from you. You can also find me on Twitter at DavidShattuck8. In case you were wondering, the 8 does have special meaning to me. It means that there are 7 jerks in the world named David Shattuck who picked their Twitter handles before I did. So that's why I'm David Shattuck8. So the lady killer in the picture with me is my nephew, Jude. And to just kind of get this talk started off on the right foot, let me predict that he will, over the course of his life, probably do more transactions with cryptocurrency than with fiat money. But let's put that aside for now. Okay, so what are we doing today? What are we doing with this meeting? Well, 4 years ago, in November 2017, I gave a talk at another Smart Data Lunch and Learn. That talk was called Blockchain: Bitcoin, Ethereum, and the Future of Everything. And in that talk, I gave an overview of sort of the origins of blockchains, the mechanics of how they work, and we talked a lot about interesting use cases for cryptocurrency. So yeah, we talked about nodes on the Bitcoin network and how they validate transactions and blocks. We talked about the contents of a Bitcoin transaction, like what it's composed of. I had a whole segment where I explained the mechanics of proof of work mining and why it's important. And we even did a code review and a live demonstration of a smart contract that I had written and deployed to the Ethereum network, which had created my very own personal cryptocurrency. So right there in front of a live studio audience, we did we broadcast transactions to the Ethereum mainnet, issued some coins, transferred some coins around, and we actually updated the state of Ethereum during a lunch and learn. So it was, if I do say so myself, a really cool presentation. Like, boy, I crushed it. Like, it was it was really good. And it was also apparently a funny presentation. So here's a picture of everyone laughing. Seems I even cracked myself up. Yeah, everyone just having a good time. Everyone except Mike Martin scowling in the corner there. So everyone else had a good time. So the presentation was very well received. And over the course of the next 18 months or so, I ended up giving the talk another half a dozen times or so at an assortment of venues. So this is me giving the presentation at the .NET Developers Group. I also gave the talk at a real hoity-toity C-suite executives only meeting down in Cincinnati. I spoke at ComSpark a few years ago. And the most common question that I received, after giving the presentation was, is this talk available online? I'd love to share it with somebody. So I ended up recording myself giving the presentation, and I put it up on YouTube. You can find it there today. It's got a couple hundred views on it. And overall, it was just, it was a great presentation. It was a lot of fun. So that's cool and everything, but what are we doing today? What is this meeting about? I didn't answer that question during my little historical survey there. Well, in the concluding remarks of that presentation, I made 2 predictions about the future of blockchains. My first prediction was to say that the world has a very real need for a decentralized planet-scale state machine. So basically a world computer that is not owned by anyone, so no one can control it, no one can shut it down, but everyone is free to use it. Anyone can write code for this computer, anyone can execute code that is deployed to this computer. And so I said, given that this huge need exists, my first prediction is that Ethereum, or something very much like it, is going to be big, like not just big, huge. And so my second prediction was like the first. I said that the world has a very real need, and I would even go so far as to call it a desperate need, for a decentralized planet scale peer-to-peer electronic cash system. So a network that enables any person in the world to send any amount of money to any other person in the world, anywhere else in the world, instantly and for free, and with no middleman. And couple that with a currency that nobody controls. So this is a currency that is immune to the whims of the corrupt and or incompetent politicians that happen to be making monetary policy decisions at any given time in any given country. So my second prediction was to say that given this desperate need for a system like this, I predict that Bitcoin Cash, or something very much like it, is going to be big in the future. And again, not just big, huge. So what I'd like to do with this presentation today is revisit those two predictions. So 4 years have passed. How are things going? How are my predictions shaping up so far? So keeping that in mind, let's look at the agenda. This talk is going to be broken roughly into 2 parts. The first part will be all about the first prediction. So we'll look at Ethereum and we'll look at how it's been doing over the last 4 years. And then the second part, we'll be talking about the second prediction, Bitcoin Cash, how it's doing, what changes have happened in the last 4 years. Okay, let's go ahead and jump right into it. We'll start out by talking about Ethereum. So as a reminder, Ethereum is a blockchain-based smart contracts platform. Now, it is a special member of that group of projects because Ethereum was the first of its kind. Nothing like Ethereum existed before Ethereum. So it has been, I would call it the forerunner of this space. So we want to ask the question, how has demand been to use Ethereum? My prediction was that a lot of people are going to want to use this. Let me suggest that one of the best metrics that we can think about with respect to are people using it is to look at transaction count. If people are using it, transactions will be getting processed. So here is a chart of the number of transactions processed per day on Ethereum over time. Now, I made my prediction right about there, right? So November 2017. Now, you can look at this chart and say, yeah, it looks like, there's a general uptrend to this. Like this is going in the upward direction. And indeed, it looks like the number of transactions per day has more than doubled. So yeah, okay, good. Way to go, Ethereum. That's not bad at all. However, this chart does not tell the whole story. You see, Ethereum has a transaction capacity limitation. Now, the limit of the number of transactions that can be processed per day varies because transactions vary in complexity. But roughly speaking, Ethereum is capped right about there. So this red line represents a soft limit to Bitcoin's capacity. So all that we can really glean from this chart is that Ethereum has been operating at 100% capacity for the last 18 months. Since, July of 2020, every square inch of space on the Ethereum blockchain has been used for transactions. So let me suggest that a much more useful, much more interesting metric to look at is going to be the price, not the price of the Ethereum coin, the price to perform one Ethereum transaction. So that's what we can see on this chart. So again, my prediction right about there. And in the time since I made my prediction, 4 years, the average cost to conduct an Ethereum transaction has increased by approximately 20,000%. So we have a classic supply and demand problem here. There is enormous demand to use Ethereum, but there is a finite supply, a very small supply for space in the Ethereum blockchain, And so the result has been crazy fees to use the Ethereum network. The fees have been so high. This is a screenshot I captured from a transaction visualizer. The median cost for performing a contract transaction was $440. I have seen this as high as $1,000. This means that if I were to try to do my Coin demonstration, the one that I did in the first talk, if I tried to do that today, it would cost me hundreds of dollars. So clearly there's demand, but also clearly there's a problem. There's a couple of problems. So we can define the two problems like this. The first problem is that Ethereum is very inefficient. So, and by that I'm talking about the metric of energy consumed per transaction processed. Ethereum is a proof of work chain, so a lot of energy is being used around the world to try to mine blocks, and the number of transactions being processed is very small, 15 per second, in fact. So energy per transaction, very inefficient. And of course, the second problem, like I've just been saying, the supply of transaction capacity is far short of the demand for transaction capacity. So the result is that this is very expensive to use, and much more critically, a lot of use cases are priced out. There are a lot of people who want to use Ethereum to deploy their applications to it, to spin up their businesses around it, but they simply cannot when it's $50, $100, $1,000 to perform a transaction. So Ethereum, in a very real sense, has been a victim of its own success, and it's facing two serious problems. However, there is a set of solutions on the horizon that are collectively known as Ethereum version 2.0. So Ethereum 2.0 is a set of upgrades. It's a collection of independent upgrades that together are known as Ethereum version 2.0. We're actually in flight on this right now. Like, some of the version 2.0 upgrades have already been deployed, and some of them are still ahead of us. So let's think about these two problems and talk about the solutions that version 2.0 offers with respect to solving these two problems. Okay, first problem, as I mentioned, the proof of work consensus mechanism that Ethereum is using is sucking a lot of energy. Like, just huge amounts of power are being directed towards mining Ethereum blocks. Ethereum 2.0 offers a solution to this problem in the form of migrating the entire system to using what's known as a proof of stake system. Now, we'll talk about how proof of stake works in just a minute, but the important takeaway point for this slide is that proof of stake is a much more environmentally friendly consensus algorithm because it uses a teensy tiny fraction of the power that proof of work does. Okay, why is that? How is that a thing? Well, let's revisit this slide from the first talk. Now, in my first talk, I gave sort of a detailed explanation of how proof of work mining operates. So I don't want to rehash all that here. Get that rehash. I don't want to rehash it here. Yeah. Okay. Sorry. Okay. But quick review of this this last slide. All of the proof of work miners in the entire world are going through this cycle all the time. So they're putting a bunch of hashes into a hashing algorithm, examining the output of that algorithm, and seeing if it's lower than some target. All of the miners are doing this all of the time. It's happening hundreds of quintillions of times every second. Now, what I want to draw attention to is this black box that's labeled hash. The amount of energy required for a computer to do one hash is very small. Like, it's tiny. But if you're doing it hundreds of quintillions of times every second, that can really add up. And the result is Ethereum consuming a lot of energy to find blocks. So let's think about proof of stake mining as a comparison. So in proof of stake mining, what you have instead is that a miner is selected at random, quote unquote, at random. With proof of work mining, all of the miners are trying to find a block. In proof of stake mining, one miner is selected by the system to create the block. Now, I quote unquote at random. There are variables that affect the likelihood of any given miner being selected. So the amount of coins that they have staked, the time that they have spent as a miner, the time that they have been online, like their online time, their propensity to create valid blocks versus invalid blocks. These are all variables that play into any given miner's chances of being selected to produce a block. So when a miner is selected, they will create a block. So they'll put all the transactions into it that they want. They will put in the Coinbase transaction, which gives them newly created Ethereum. And then they will broadcast that block to the network so other miners can validate it and add it to their copy of the blockchain. And then the process repeats itself. So this is the proof of stake cycle. What I'd like you to notice about this cycle is that there are no computationally intensive steps on this. It's very easy, quote unquote, easy to do for a computer. So the amount of energy required is just a tiny, tiny fraction of what's required for proof of work. So thinking about these two competing options, proof of work and proof of stake, I think the best way to understand them is to think about the ways in which they are the same and the ways in which they are different. So on the left, I've got the ways that they're the same, and on the right, I have the ways that they're different. So first of all, the ways that they're the same. Both of these are consensus algorithms. Their purpose is to facilitate a network full of strangers, a network full of people who don't know each other and don't trust each other, facilitate this group of strangers reaching a state of agreement about the state of the blockchain. They both do that same thing. The important difference is proof of stake does that without consuming, a country's worth of electricity. Another thing that's the same is that in both of these situations, the miners who want to work to secure the network require to invest capital into the system. Now, with proof of work, what they're investing in is dedicated hardware like graphics cards and ASICs. They also have to invest in electricity. But with proof of stake, the miners have to invest in the coins. So they have skin in the game, so to speak. They have an incentive to keep this network secure and valuable because they own the coins representing this network's value. The third thing that's the same is in both situations, only one miner finds the next block. In proof of work, everyone's looking for the block. In proof of stake, the system selects the miner to make the block. But in both cases, one miner makes the next block. All the rest of the miners add the block to their blockchain. So the difference is the number of miners that are looking for that block. And finally, in both situations, any given actor who has the capacity, has the ability to attack the network can make a lot more money by protecting the network instead of attacking. The difference is what any given attacker loses if they try. So if you're a proof of stake miner and you're trying to do some wonky stuff, your stake is slashed, so you lose coins. Whereas if you're a proof of work miner, what you're wasting is the energy that you spent money on. Okay, so that's the solution to problem number one, is proof of stake mining. What about problem number two? Remember, problem number two is 15 transactions per second. Ethereum can process 1.2 million transactions per second, which is nothing. It's chicken scratch. Like if you want to be the backbone of the global economy 10 years from now, you're going to need to process more than 15 transactions per second. So the solution that Ethereum 2.0 is introducing is sharding. So those of you who have been, database administrators on large scale will recognize sharding. It's just the idea of breaking a system up into smaller pieces that are working together to facilitate storage of data. So what does that look like on a blockchain? Well, let's imagine that we have a blockchain here. We'll call this blockchain A. And we'll say that blockchain A has a capacity of 15 transactions per second. And we say, we want to bump this up. We want more than 15 transactions per second. So we create another blockchain, blockchain B, and that blockchain also can process 15 transactions per second. Now, you might think, okay, great, that's 30 transactions per second. But no, what you have here is two fully independent blockchains that have nothing to do with each other. A user of one system cannot interact with an application on another one. However, if you have a third chain that is operating as a coordination layer and kind of facilitating the interaction between these two chains, what you have then is a sharded blockchain. So this graphic on the screen represents a sharded blockchain with one coordination layer and two shards. So the coordination layer handles the consensus mechanism. So proof of stake is running here, but then all the processing, all the transaction processing happens in the shards. Now this scales linearly. So 15 transactions per second per shard. If you've got two shards, you're now at 30 transactions per second. Okay, cool. But 30 is still basically equal to 0 when you're talking about global adoption. So what is the plan for Ethereum 2.0? Well, this is an image that I took from the blog of Ethereum founder Vitalik Buterin, where he's talking about this mechanism in the Ethereum space. You can see at the very top of the screen, there's the beacon chain, the coordination layer. That's what the beacon chain is, or the beacon chain is the coordination layer in version 2.0. And you can see we have two shards on the screen here that are interacting with sort of the central spine, the beacon layer. But notice, even though there's two shards pictured, one of them is labeled shard 64. So when Ethereum 2.0 goes live, it's actually going to have 64 shards that are all capable of processing 15 transactions per second. And so we're going to be looking at about 1,000 transactions per second. Now, this is a lot better, like 1,000 transactions per second, still pretty good, but there's room for improvement. Let me draw your attention to the fact that some of these chains are labeled data layer. Some of the chains in Ethereum version 2.0 are not going to be transaction processing shards. What they're going to be instead is data storage shards that are there simply to facilitate layer 2 networks. So a layer 2 network is an independent network that is built on top of Ethereum that settles to Ethereum. What do I mean by that? Imagine that Alice and Bob have some sort of interaction where they are transacting back and forth 10,000 times per day. Well, they don't need to write all 10,000 transactions to the Ethereum blockchain. What they can do is move those 10,000 transactions to a second layer network, and then every so often, maybe once per day, update, like send one transaction to the base layer that updates the state of their two accounts, and then reduces the amount of noise on the base layer. So these data layers are going to be dedicated specifically to facilitate these second layer chains. Now, there's a whole bunch of these out there in the world right now. Polygon is probably the biggest, most well-known one, but there's a whole bunch of them. The official estimation from the Ethereum Foundation is with the sharding plus the second layers, Ethereum is going to be looking at about 100,000 transactions per second. So now we're cooking. When this goes live, serious business, fees will plummet to almost nothing. It'll be opened up and anyone can deploy whatever they want to the network. I'm super jazzed about it. Okay. So we've got these two serious problems. We've got these two proposed solutions. What's the plan for getting these up and running? Well, let's look at the timeline. So 2015 is when Ethereum started. And up until 2020, this is what the system looked like. You had one blockchain, Ethereum 1.0, a proof of work chain. This is what the world looked like when I gave my presentation in 2017. In December of 2020, the first major milestone of Ethereum 2.0 went live, and that was the launch of the beacon chain. So the beacon chain, remember, is this coordination layer that's running at the core of the entire system. This is also the mechanism that is facilitating the proof of stake system. So proof of stake is live right now on the beacon chain. It is actually running. However, one thing you might notice about this graphic that I've got on the screen now is that these two chains are totally independent. Ethereum 1.0 is running just as it always did on proof of work. And the beacon chain is not processing any transactions because the only thing going on over there is the proof of stake system. There is one link between these two right now, though, and that is that there exists a bridge that allows people to move Ethereum to the beacon chain to participate in the proof of stake mechanism. At the moment, approximately $35 billion worth of Ethereum have been migrated over. But again, that system is not validating any transactions. It's just running, just making sure that everything's good to go. Okay, so this is what the world looks like today. What's coming up next? Well, the next big milestone is currently scheduled for the first half of next year, but that date has been bumped in the past, so who knows? It might be bumped again in the future. This is all tentative. But the next big milestone is called the merge. The merge milestone represents the Ethereum 1.0 linking up and becoming officially part of the beacon chain. Now, when this happens, the proof of work era in Ethereum will officially be over because the consensus mechanism on this system will be purely and only proof of stake. When that happens, that chain will stop being Ethereum 1.0 and it will become basically Shard 1. Now, when this happens, problem number one on Ethereum will be solved. It will not be burning huge amounts of energy anymore. It'll just be, using proof of stake. So milestone number 3, which is currently scheduled for the end of next year, is going to be the launch of the other 63 chains. So, and that will bring with it the facilitation of heavy-duty second layer activity. And when that happens, we'll be at 100,000 transactions per second. So problem number 2 will be solved. Okay, so quick comment about the second part of my prediction here. Ethereum has some problems. It's got some cool solutions lined up, but my prediction was that Ethereum or something like it would be big. I want to point out that Ethereum, although it is the undisputed king of this space, does have competition. So on this screen, I've got Binance, Avalanche, Algorand, Phantom, Solana, Cardano, Polkadot, Cosmos, and Tezos. This is the rest of what I would call the top 10 of the smart contract platforms. Now, let me emphasize, Ethereum is the first, and Ethereum is still the king. You can look, for example, at DeFi contracts and see that the amount of capital locked in DeFi contracts on Ethereum is more than all of the other chains combined. So again, Ethereum is number 1. It's way out in front. But as I've been saying, Ethereum has some serious problems. A lot of these networks that I've got on the screen now have actually already implemented the changes that I'm talking about for Ethereum 2.0. So there is a very real risk that if Ethereum can't get their acts together and meet the demand might lose interest and migrate to another chain. So I'm excited to see what the future holds. But if any of these chains make it and become the chain, my prediction will be correct. So we'll do a review of prediction number 1. I'll say, yeah, prediction number 1 is going pretty good, and I'm excited to see what the future holds. I still think Ethereum will remain the king, but I don't know for sure. Okay, so let's move into part 2 of this presentation. For part 2, my second prediction was that Bitcoin Cash, or something very much like it, is going to be big. So what I'd like to do in this section is I want to introduce you to or do a review of 3 really cool pieces of infrastructure that have been developed in the last 4 years on this, on this journey, progress towards global adoption. Now, the third of these 3 things that I want to demonstrate is going to require some audience participation. Now I understand, believe me, I get it. I have been in an audience before. I know that every audience in the world hates audience participation. I understand. But I think you'll like this. I think that you will enjoy this audience participation. So what I need you to do right now, like I want you to do this right now while I'm talking, is I want you to pull out your phone and I want you to download this app, Bitcoin.com wallet app. And I mean it, like pick up your phone right now while I'm talking, go to the App Store. I want you to search in the App Store for Bitcoin and download this app, Bitcoin Wallet. It's got the black and green logo. It's got 5 million downloads, 4.5 stars. Go download this. Now, we'll come back to it, so you have a few minutes, but it should be very easy. There's no account creation that's required. You don't have to do anything special. There's no forms to fill out. Just download the app and open it. I understand, Tim. I appreciate that. Okay, so download it. We'll come back to this. Okay, what I'd like to do now is revisit something that I talked about in my first presentation. You may remember in my first presentation, I had a whole segment where I was talking about real-world use cases for cryptocurrency, and the ways that crypto is better than fiat in every meaningful way in almost every scenario. But the scenario that I spent a good amount of time talking about was a trip to the grocery store. My focus for that section was to compare credit card transactions with cryptocurrency transactions and why crypto is just way more awesome. But what I want to focus on for this presentation is this slide. So on this slide, I described a hypothetical setup that will allow the grocery store, or really any point of sale system, to very quickly and easily accept a cryptocurrency transaction to cover the cost of some purchase. So real quick, let me describe the scenario that I had set up here. So I said that I'm purchasing my Hot Pockets at the grocery store. It's time to check out. I touch my mobile device to a terminal, like a device on the terminal, and it would use some sort of near field communication to give my phone 3 things. So the 3 things would be the crypto address of the store, the total cost of the goods I'm purchasing, and the name of the store. Then I said number 3, the user would look at that information on their phone and they'd click yes to confirm I do want to make the purchase. I said then that number 4, the device would create a valid transaction and broadcast that to the network. I said then number 5, that the node that the grocery store is running to keep an eye on the network would see that transaction and send a confirmation to the point of sale terminal that the transaction has been seen and it's valid and good to go. And then, you're off and running. So I emphasized how easy this would be for the users from the user's perspective. Like, you just tap it and then click yes, and you're done. So keep this slide in mind, right, as I go into this next part, right? Okay, so I originally was thinking that this would be an in-person presentation. And so I was actually planning to show you a 30-second video. Now, things being what they are, I don't think streaming a video through here would make good sense. But it's such a good video. What I'm going to do is I'm going to storyboard it for you. So we're going to watch this video with selected one frame at a time, and I'm going to narrate it for you so you can follow along. Right? Okay. So our story opens.
This is very classic.
Oh, yeah, no, this is good stuff. So we're in a convenience store, and we've got our guy here in the front with his Bitcoin wizard shirt, and he is rambling on to the cashier about global money printing conspiracy theories and cartels and whatnot, and going on about picking the proper number of satoshis per byte of the transaction or whatever. But the hero of our story is the guy in the back, that guy with like the leather jacket, whatever. See, he's here to buy a bag of chips. Now he's got a decision to make. On the one hand, he is trying to watch his sodium, but on the other hand, oh man, nacho cheese, it's hard to resist. Now, the chips actually whisper in his ear that they want him as much as he wants them. So the decision has been made, and he is ready to check out. He is ready to make his purchase. Now, our guy at the counter is still going on. He's yelling about, to the moon and diamond hands and all the other nonsense that you hear in the crypto Twitterverse these days. But again, our cashier doesn't care about any of that. He sees the guy is ready to check out. So he says to him, that'll be 14 bits. So he's telling him the price of the chips that he wants to buy. Now notice on the counter, there is a tablet that is displaying a QR code. Now that QR code contains the Bitcoin Cash address of this store, and it also contains the cost of the chips, like how many Bitcoin Cash is required to cover the cost of these chips. So our guy uses his phone to scan the QR code, and the transaction is processed. Now, I can't really show this because it's screenshots instead of a video, but the time between here and here is a fraction of a second. I can't emphasize how fast. It's amazing how fast this is, if I'm being frank. So the transaction has been completed, and our hero turns to the crazy guy and says, "It's just money, bro." And then he walks coolly out of the store, munching on his bag of chips. Okay, so when I saw this video for the first time, I was super excited about it. And I was super excited about it for 2 reasons. The first reason I was excited about it is because it introduced me to 2 apps that I was not aware of at the time. The first app is the Bitcoin Cash Register app, which is what the cashier was using on the tablet on the counter there. Now, this app is so cool. You can set up a point of sale, like a business, to accept Bitcoin Cash in, seriously, like 10 minutes. There's no account set up. You don't have to get a license from Visa. You just download it and install it, and it's so easy. The second app that it introduced me to was the Bitcoin.com wallet app, which I now use like every day for my Bitcoin Cash transactions. It's non-custodial, super fast, super slick, super easy, and it's the one that I asked you to download a few minutes ago. And if you haven't downloaded this app yet, like seriously, you will want to have it. And if you don't have it, you won't have time to get it. So phone, App Store, Bitcoin, get this app. Okay, so the second reason why I was super excited about this video is because this video shows the real world manifestation of the system that I predicted 4 years ago. This is that system. Now, I will admit right off the bat, I was wrong about a couple of things. So let's very quickly review what I was wrong about. So first of all, I said you touch the device to the terminal. I honestly don't know why it didn't occur to me that they would use QR codes. Like, I seriously have given lightning talks to devs about QR codes and how awesome they are at moving money, or at moving information from one device to another. So I don't know why this didn't occur to me, but yeah, you don't touch the device. You just scan the code with the camera that every phone has. I was mostly right about number 2. The QR code contains the address and the cost, but it doesn't need to include the name of the store. It could include the name of the store, but most people will know what store they're in, so you really don't need this. Now, I was kind of right about number 3. The app can be configured, so if you want it to, you can say, hey, if the payment is more than X, I want to do a review and a confirmation. But the guy in the video had it set to just, when you see the QR code, just immediately send the transaction. So you can do this step if you want to, but I'm going to cross it out because you can also skip it. So I was right about number 4. The device broadcasts, like it constructs a valid Bitcoin Cash transaction and broadcasts it to the network. I was wrong about part of number 5. I knew that some computer would need to do this step, but I assumed at the time that the grocery store would be handling that. Like, they would have a node that's watching the network for any transactions that it cares about. But in this case, Bitcoin.com does that for you. Like, it sees the transaction as soon as it hits the mempool, and it will send a notification to any device that cares about it. So this whole step, like this thing of the grocery store managing that, no, they don't have to do any of that stuff. They just download the app and it's good to go. Now, that's not a security vulnerability because Bitcoin.com doesn't have any of the private keys. It's just saying, oh, hey, this transaction that you care about, I see it in the mempool, so I'm letting you know about it. And of course, Bitcoin.com sends that payment confirmation to the point of sale terminal. So yeah, I saw this and I was super jazzed about it. Now, I was mostly right, but I was wrong about one key thing. Okay, when I presented this the first time, I said I emphasized how easy this would be for the user. You touch your device to the terminal, you look at the screen, and you click yes or no. How could it be easier? But I was wrong, because in reality, it's even easier than I thought it would be. Like, seriously, you scan the QR code, boop, oh, you're done. That's it. You don't have to do anything else. You're done. Okay, so this has been the first item on our list of 3 things for Bitcoin Cash we want to talk about. Let's move on to number 2. So for number 2, I want to talk about, this is an idea that I have been thinking about for the last year or so, and that is subscriptions. Now, I'm talking here about just subscriptions in general. Almost certainly everybody on this call is subscribed to something. Your internet service provider, you're subscribed to Netflix, you're subscribed to the trash service where they come and pick up your garbage. Like, there's subscriptions all over the place in the world today. But thinking about this in the cryptocurrency world, I think subscriptions is another scenario where cryptocurrency provides a meaningful disruption to the way we've been doing things for a long time. The way we've been doing things for a long time has a lot of stupid stuff in it, and it's just stuff that we don't think about anymore because we're used to it. Let me talk through what I'm thinking about here. So, first problem with subscriptions, almost always you're using a credit card or a debit card of some kind. So you immediately inherit all of the problems that we talked about last presentation with the grocery store. So they're incredibly slow, they're incredibly expensive, and both parties are vulnerable to fraud. So that's lame. Right off the bat, it's stupid. But this subscriptions model is even worse than the grocery store example, because at least with the grocery store, you can pretend that they don't keep your credit card information after the fact, and they just get rid of it. With subscriptions, they have to keep your sensitive payment information because they need to do the charge once every month. So what you're left with is very large, in some cases, millions of records of databases filled with payment information, that's bad. These are prime targets for hacking attacks, and we have seen breaches on many occasions in the past. So that's lame. You also, in a lot of these subscriptions, will have an associated contract. So there's a duration. I'm thinking here specifically about like your cell phone bill. You say, okay, I want the subscription, and they say, okay, that'll be 12 months. You give them your credit card. 3 months into it, you change your mind. I don't want the service anymore. well, that's tough beans. You can cry about it. They're going to continue charging you every month until the contract ends. The next thing is these companies have a financial incentive to make it easy to sign up and difficult to opt out. So yeah, sign up on our website. It's super easy to do. But if you want to opt out, you need to call us and you need to migrate your way through our robot phone network, and then you need to get someone on the phone and you need to convince them to unsubscribe you. So that's lame. You also have this thing where you're subscribed to something, you stop using it and forget about it, but you forget to, unsubscribe officially. They will happily keep charging you for that, even though you're not using it. And finally, this is a minor one, the idea of group subscription. So there are some services that people as a group subscribe to. My favorite example is Discord. So, you've got a group of, 15 people that are using a Discord server to play games and stuff, but one person, some hero, is like, hey, don't worry, guys, I'll pay for the Discord server and everyone can use it. There's nothing wrong with that, but it would be cool if it was really easy to subscribe to something as a group. Okay, keeping all these lame things in mind, let's think about what subscriptions would look like in the cryptocurrency world. So I'm going to describe a model for how a business could support subscriptions using crypto. Okay, step one, you subscribe to a service. You say, hey, company A, I want to subscribe to your super cool service. So step two is that company A, will give you three things. The first thing that they will give you is a unique cryptocurrency address. The second thing that they will give you is your current expiration date. So maybe the first 30 days are free, and so they will give you an expiration date that's 30 days from today. And the third thing they will give you is the rate. How much does it cost to keep this subscription active? So for example, maybe it's 30 bits per month. Okay, so those are the three things they give you. Now, if you like this service and you want to stay subscribed to it, all you have to do is send as much money as you want to this unique crypto address that they've given you to keep the subscription active. Because what will happen is when their system sees that money has been sent to your unique address, they will push out the expiration date by an amount equal to whatever you sent. So again, for example, 30 bits per month, if you send 90 bits to your address, they will extend the subscription by 3 months. And of course, they could play around with the business logic. Maybe they want to incentivize people to send a whole bunch of months at a time. So they say something like, hey, if you send more than 180 bits, then your subscription rate will be 25 bits per month. So stuff like that. And then very simply, the service becomes inactive whenever the expiration date is in the past. So as long as you're using the service, you send the money to it, and it will push your expiration date out. Okay, so let's compare that idea with the way subscriptions work today. First of all, credit cards, slow fees and fraud. With cryptocurrency, it's instant, free, and safe. So that's a step in the right direction. In the old days, you have a database of payment info, and you don't have that with cryptocurrency. No personal information ends up in the hands of the company that you're doing business with. It's difficult to opt out of the old system. If you want to opt out of the new system, do literally nothing. Like, that is how to unsubscribe, is to do nothing. With this cryptocurrency model, you choose the duration rather than having a locked-in duration, which is much better. You don't pay if you forget, and group subscriptions are very easy to do. And I actually want to show you an example of a group subscription. So I really have been thinking about this idea of using cryptocurrency for subscriptions. I have been thinking about it so deeply, in fact, that I actually built the system that I'm talking. I have made this in code. And I have put it in one of my pet projects, which is called A Fifth of Gaming. So very quick introduction. A Fifth of Gaming is a web application that I created to help my friends and I organize game nights. So we all like playing video games together. Unfortunately for me, all my friends are much better at talking to girls than me. So they all have, wives and kids. Like, they have lives that they're living. And, children and wives, as I understand it, introduce a certain degree of complexity into your life and into your schedule. So the problem that we were facing was it became very difficult to find time to get together and play a game unless somebody meaning me, went to the effort of coordinating with everyone individually, comparing schedules, and like, okay, here's the time block, and figuring out what game to play. So I created a fifth of gaming to automate that process and make it easy. And I'm going to swap over to it real quick here. So this is the app. This is the detail page for the group that I'm in, Guild 1. This is our guild. So these 5 games at the top are the top 5 all-time games that we have played. And let me make a quick note here. We have been using this app for several years and have scheduled hundreds of game nights. So it's got a bit of a history behind it. So Gunfire Reborn is what we're playing right now. We actually had a session last night with that 6 people came to, and coming up next is Valheim. So what this system is doing basically is it schedules the sessions, it sends email reminders to people who are part of the guild and might want to participate. It handles attendance tracking, so you can keep track of who is there, and it also handles the game selection using a fully automated process of game nomination and voting. Now, what I want to emphasize for obviously the context of this presentation is this tab, the Fund tab. So I have set up a fifth of gaming so that whenever anyone creates a new guild, and by the way, this is open, so like anyone can come in here and create their own guild for their own group of friends. But whenever somebody does that, a fifth of gaming, the web app, will create a new Bitcoin Cash private key for that guild. And that key is stored encrypted in the database. And it will also generate a Bitcoin Cash public address for that guild. So remember the 3 things that I said a company would give you if you were using cryptocurrency subscriptions. Number 1, they give you the address. Number 2, they give you the end date. Number 3, they give you the rate. So on this page, you can see there's the address, there's the end date, and down here there's the rate. So I've set the rate for using my little web app as $1 per person per month. The main reason I did this is because I wanted to try this and I wanted to give people an excuse to play with Bitcoin Cash. So this is not a money-making venture by any stretch of the imagination. But what's happening in the background here is really cool, if I do say so myself. Once every few hours, a fifth of gaming will check the Bitcoin Cash blockchain for any unspent transaction outputs that are linked to any of the public addresses that belong to any of the guilds in the system. If it finds any of those, it means that somebody has sent money to their guild address. So it will calculate the amount of time to add based on how much they sent and how many people are in their guild, and then it will push the expiration date out based on how much they sent. So you can see this table here is showing all of the transactions that have been sent to fund this guild, the one that I'm in. So there's a link here. You can click on any of these to actually go to the Bitcoin Cash block explorer and see the transaction on the blockchain. And you can also see how much was sent and the amount that the date was pushed out every time. Okay, so coming back to the main point of this section, I want to look at 3 things that didn't exist 4 years ago that exist now in the Bitcoin Cash space that are super cool. One question that you might be wondering is, how did I do this? How did I implement Bitcoin Cash transactions in just a regular run-of-the-mill C#.NET web application? Like, this app is both reading and writing on the Bitcoin Cash blockchain. Well, when I set about to do this, there was not a lot of documentation out in the world. So I actually went and created some of my own. So I have written a post on read.cash that provides very detailed instructions on how to create a simple C# console application that can both create Bitcoin Cash transactions and broadcast them, and also read from the Bitcoin Cash blockchain for fetching information from it. Now, what I want to point out here specifically is actually I've passed it already. This NuGet package. So there's a C# library called nBitcoin, which creates a layer of abstraction between we, the regular devs, and the very nitty-gritty stuff of blockchain transaction creation. So this library supports lots of chains. Obviously, I'm a big fan of Bitcoin Cash, so I'm using it for that. But the sort of things that I'm talking about, if you want to do those for some other cryptocurrency, and Bitcoin will support it. So yeah, I was originally planning to do like code review and talk through some of this stuff, but there's a lot of non-devs in the call, and I don't want to, glaze over anyone's eyes. But I'm sharing this with you. So if you are a dev and if you are interested in implementing cryptocurrency transactions in your application, check out this blog post. I created it because I had so much trouble finding documentation. I made all the documentation myself, and it's very detailed, very step-by-step, explains everything along the way, and there's complete code examples of the entire application available the whole way through. Okay, so that was number 2. Let's jump into number 3. And here now we have reached at last the audience participation segment that I promised. So you've downloaded the app by now, at least I sure hope so. Otherwise it's too late. Let me explain how this is going to work. So on the next slide, you're going to see a whole bunch of QR codes that look kind of like this, right? So this is an example one. Now, what I'd like you to do, and the one that's on the screen right now is a test one, so go ahead and try this as I'm explaining it. I'd like you to open the app and find the button in the top right corner that looks like that. So it's got a little QR code with little brackets around it. So go ahead and push that button. The phone should ask for your permission to use the camera. Go ahead and grant that. And then scan this QR code that I have on the screen right now. Now, when you do that, you should get a message that says something like, "Oh, I tried to process the payment, but there's no funds available," or it'll say something like that. And the reason it says that is because this QR code has already been used. This is just an example. But I want you to kind of get in the flow of I want you to get in the flow of scanning the QR code with the barcode or with the camera. Now, the reason I want you to understand how to do that is because the next slide I mentioned with the QR codes, those are not empty, right? The QR codes on the next slide contain approximately $100 worth of Bitcoin Cash. And it's all varying amounts. I think the smallest one is like $1. The biggest one is like $14. I want you to be ready. I'm going to have the next slide up for 60 seconds. And this is what I'd like you to do. Scan the QR code. You'll get one of two messages. The first message is, "Hey, payment processed, payment received," and you should see the money in your wallet. The other message that you might get is, "No funds available." Now, if you get that message, it means that someone else in the audience has already claimed that Bitcoin Cash. So go ahead and try a different one. Now, if you get a payment from one of these codes, please type in the chat how much you got. That'll tell me whether or not this stunt is working. And I'd also like to keep an eye on the amounts that's coming through. There's a couple that are bigger than the other ones, and I want to make sure those get claimed before I move on. Okay, so is everyone ready? Here we go. It's 60 seconds. 60 seconds on the clock. Here we go. 3, 2, 1, go. Okay. Have at it. Yeah, so I should probably say, like, I have never done this before, and I have never seen anyone else do this before. So I think it'll work. I hope it works. Okay, I see some numbers coming in, so let's go. Let's go.
Just reading some of them off, we've got 107, 316, 106, 842, 845, 107.
Nice.
201, 107, 318.
I'm super jazzed at this. I was a little worried about the resolution, like it might be too small, but yeah, seems like it's working.
528.
All right, we've got about 20 seconds left. Keep scanning. Keep scanning. There's a big one that I don't see that's come. I mean, big. It's not huge. It's like $14 or whatever, but I haven't seen that one come through. Okay, and I'm gonna say that's time. Okay, so that was cool, right? Like, wasn't that pretty awesome? So the question is, how did I do that? How could I possibly how could I possibly have sent money through a PowerPoint slide? Like, you guys provided no information. You didn't give me your name, you didn't give me your email address, you didn't give me your phone number, social security number, bank account information. You didn't even give me your Bitcoin Cash address. How did I send you money? Well, what I'd like to do is explain to you how that mechanism worked. Now, the reason I know how it worked is because I was chatting with my very good friend Roger Ver about this, and I wrote a post where I speculated, like, here's what I think is happening in the background based on what I'm seeing happen in the foreground. And Roger Ver hopped in and said, yep, you're right on the money. One minor correction, but otherwise, I was spot on with my kind of speculation about how it works. So I'm gonna relay to you what I was talking about. Now, I should very quickly, for the sake of honesty, I'm not Roger Ver's friend. I'd like to be Roger Ver's friend. So Roger, if you're watching this, drop me a line. Let's get coffee. But Roger Ver is one of the legends of Bitcoin history, and I was super excited to talk to him on Reddit for even just a couple minutes. Anyway, let's talk about the mechanism that I just used. So this slide, I think, is probably going to get a little bit chaotic because I'd actually like to do two things on this slide at the same time. So the first thing, as I said, is I'm going to explain how the thing that we just did, how that works. But the second thing I'd like to do is everyone who just received money from me, I'd like you to send some of it back. Not a lot. I want you to send 5 cents back to me, okay? So this is what I'm going to do. I am going to pull up my phone here, and I'm going to put my Bitcoin Cash address on the screen, along with some instructions. Now, they're very simple instructions. You could probably figure this out without using them, but I put them there just in case. So what I'd like you to do is when my Bitcoin Cash appears on the screen, I would like you to send me 5 cents. And I'm going to, while I'm talking, I'm going to hold my phone up like this. So I'm doing this for 2 reasons. Number one, I want you to see how easy this is, okay? These are real, actual cryptocurrency transactions. You are constructing valid Bitcoin Cash transaction and sending them to the real, actual Bitcoin Cash network. The second thing I want you to see is how fast this is. The reason I'm holding my phone up like this is because I want you to watch. When you click slide, watch for the pop-up to happen on my screen, and you can see how fast it is. Okay, ready? Here we go. There's my Bitcoin Cash address. There's the instructions. Now I'm going to jump into the explanation of how the thing that we just used worked. Okay, so to send Bitcoin Cash through a PowerPoint slide. Oh, yeah, got one. Oh, geez, my phone's blown up. Oh, man. Yeah, okay. I thought that would take a minute for it to come, but oh, man. Look at that. It's like I'm a performer on stage and people are throwing nickels at me. Okay, so while that keeps chiming, let me explain the PowerPoint trick. Okay, so there's several components here. First component is the app on my phone. So when I installed this Bitcoin.com wallet app, the app automatically created for me a new Bitcoin Cash private key. So that basically is my wallet. Now, the other pieces of the puzzle here are Bitcoin.com and their servers, a third-party data storage system. So this is just one of those places that you send data, they encrypt it and store it for you. Fourth component, of course, is the Bitcoin Cash network and the blockchain. And the final component is your app. So you downloaded the app, and as soon as you opened it, it created a Bitcoin Cash private key for you. And so now you have your very own wallet. Okay, here's how this goes. Step 1, when I do a shareable link, is my app will create a new Bitcoin Cash wallet. So it creates a new private key and a new temporary wallet. The second thing that happens is it will broadcast a transaction to the Bitcoin Cash network. Now, this little icon here that I've got of the orange square pointing at the blue square, that represents a transaction that's moving the money from the orange wallet to the blue wallet. So that's how to understand when you see this symbol. Okay, so a transaction broadcasts the Bitcoin Cash network that moves the coins from my wallet to the temporary wallet. Okay, so once that's processed, you can see the Bitcoin Cash has moved to the temporary wallet. The third thing that happens is my app creates another transaction. This transaction sends the coins from the temporary wallet back to my wallet. I'm going to go ahead and put my phone down so I don't have to hold it the whole time. But you got the idea. You saw what happened. Okay, so this third transaction sends the coins from the temporary wallet back to my wallet. Now, I don't broadcast that to the Bitcoin Cash network, because if I did, the coins would just come right back to me, and obviously that's not what I want. What we do instead is we give that transaction to Bitcoin.com, and they don't do anything with it; they just hold it. But we'll come back to that. Okay, the fourth thing that happens is my app uploads the private key of the temporary wallet to the third-party data storage. So gets put right there, and in response, the third-party data storage gives me back a link to the private key, right? So my phone now has the link to the private key in storage. The sixth thing is that my app gives your app the link to the private key. Now, the way we did this today is that we used QR codes. So I put the link to the key in the QR code, and that's what you scan on the screen. But you don't have to do it that way. You can do it. You can send somebody a text message with the link. You could send it to them in an email, like any way that you can get this link to the person. They click on it. If they don't have this app, they're prompted to download it, and then it immediately opens it. Long story short, step 6 is I give the link to you. Okay, step 7, your app downloads the key from the private store, from the data storage in the cloud. Your app then uses that private key to recreate the wallet in your phone. And remember, this wallet has the Bitcoin Cash in it, right? So now the two wallets exist on your phone. The ninth thing that happens is your app uses the private key of the temporary wallet, which you now have, to broadcast a transaction to the Bitcoin Cash network that transfers the coins from the temporary wallet to your wallet. And then, of course, once that's processed, you can see the Bitcoin Cash will move into your wallet. And there you have it. Now, this is so cool. You can give Bitcoin Cash to anyone, even if they don't have the wallet installed yet. Like, you can just give them the link, and this all happens. The second reason this is really cool is because no private information is transacted. So even though I put money in a wallet and gave you the wallet, neither my private key nor your private key is exposed to anyone. The only private key that moves is this temporary wallet one, which just gets thrown away. But then the other reason that this is so cool is, like, again, these are real transactions. There's no custodian. There's no one that's like moving the money on your behalf. These are actual real cryptocurrency transactions. Okay, so the very last step for this is, let's say I give you a link to this and you don't actually use it for anything. 30 days after step 3, where I gave the link to, or I gave the transaction to Bitcoin.com, they will broadcast that transaction to the Bitcoin Cash network. So if you don't redeem those coins for whatever reason, when this transaction gets broadcast from Bitcoin.com, those coins will be sent back to me. Now, if you have redeemed the coins, then when this transaction gets broadcast, it'll just get ignored by the network because it's an invalid transaction. So the coins aren't in that wallet anymore. But it's just kind of a safety net. Like, I give these links out like candy to people, and if for whatever reason someone doesn't, renew it, it'll just find its way back to my wallet eventually, which is super cool. Okay, so let's revisit my prediction. Prediction number 2. I said Bitcoin Cash or something very much like it. I want to say a few words about other projects. Just like with the case of decentralized smart contract platforms, there are other projects in the space of electronic peer-to-peer cash. So Bitcoin Cash is the king right now. It is the leader by a comfortable margin in terms of amount of usage and adoption and infrastructure, all that fun stuff. But there are others, like there are competitors in this space. And I will also say that the lead, like the gap between Bitcoin Cash as number 1 and Monero, which is number 2. And by the way, Monero is a really cool project. I love Monero, but yeah, the gap between Bitcoin Cash and number 2 is not as big as the gap between Ethereum and number 2. So yeah, I just want to full transparency. Bitcoin Cash is the leader, but there are others, and I'm excited to see which, if any, of these become the king in the long run. So how am I doing on prediction number 2? Well, I'd say I'm doing it's okay. Like it's not great, it's not terrible, it's So given all the cool stuff I've been talking about, why am I saying my prediction is Well, there's two sides of the coins here. On the one hand, there has been a lot of great progress with respect to infrastructure stuff. Just in this presentation, I have showed you 3 super cool pieces of infrastructure that did not exist 4 years ago. So the proof of sale mechanism didn't exist 4 years ago. I predicted it 4 years ago. I described it 4 years ago, but it didn't exist 4 years ago. The second thing I showed was the NBitcoin library, which is a really great tool for getting devs, like regular non-blockchain devs, up and running with implementing cryptocurrency transactions into average everyday applications, which is super cool. And the third thing that I demonstrated is like modern, super sleek, super easy to use, non-custodial mobile wallets, which make like cryptocurrency transactions extremely accessible for just anyone who has a phone. But there are other super cool things I didn't even talk about, like Smart BCH is a contracts platform that's built on top of Bitcoin Cash. Like shuffled Bitcoin Cash is, or Cash Shuffle is like a way to wash Bitcoin Cash if you're doing drugs and stuff and trying to hide money. Like that exists too. Like and even more than just the infrastructure stuff. Like even at the protocol layer for Bitcoin Cash, there are regularly scheduled upgrades to the Bitcoin Cash network. They used to do them once every 6 months. Now they're once every year. Basically, it has been an uninterrupted stream of really good news surrounding Bitcoin Cash for the last 4.5 years. It's just been, everything's been awesome. But I said, that's on one hand. On the other hand, adoption has been it has been disappointing to me, the level of adoption that we have seen so far. When I first got into cryptocurrency, I said, it's amazing. Like it's so much better than everything else by a long shot. The whole world will be using this in 5, maybe 10 years. And it hasn't happened. Like I exist in a state of sort of perpetual puzzlement where I'm like looking at the world and I'm saying like, hey, there's a long list of serious problems that we could solve right now if we switched to cryptocurrency. So what's the holdup? Like, what are we doing? Why are we not doing this? And I understand like change is scary. Like change is, even change for the better, people are often uncomfortable with it. And I don't want to create the impression that Bitcoin Cash is just some slob coin that no one's using for anything. Like Bitcoin Cash processes like $5 billion worth of transactions every day. It is a top 5 coin in terms of the amount of value settled on chain. But my question is, why isn't it $5 trillion? Why is it only like a paltry 5 billion when it solves so many problems? Why aren't people using it? Now, part of the problem, and this is true, part of the problem is the entire narrative surrounding cryptocurrency has been so thoroughly perverted from what it used to be. In my day, in the good old days, the glory days, everyone in the space was like, we're going to change the world. This is a revolution. We are going to fix so many problems that exist that are caused by fiat money and all the legacy systems that are involved in moving it around. And today, like most of the people in the cryptocurrency space, it's just a giant gambling game where you try to predict which pointless, utility-less, animal-themed nothing coin is going to be mentioned next by Elon Musk or, you know, whatever Twitter crypto influencer we're talking about. And I think that's really unfortunate. I'm trying to do my part to say to the world, like, hey, this is really awesome. It's really useful, and, you know, try it out. Look how cool it is. But yeah, it's unfortunate. I think eventually reality will catch up with this, and projects that don't do anything will just be replaced by projects that are awesome. And Bitcoin Cash is awesome. Okay, so prediction number 2, good and bad. I'm happy to keep doing my part to move the revolution forward. I love showing people Bitcoin Cash. I made a shirt. I was thinking about wearing it, but I didn't. I made a shirt that says, "I'm giving away Bitcoin Cash. Ask me." And strangers come up and I'll just, you know, here, install this wallet. Here's $5. Here's $5 of Bitcoin Cash. Okay, so let me leave you with some links, some stuff that I talked about. Ethereum has a page dedicated to version 2.0. It's really cool. Check it out. The It's Just Money Bro video is awesome. I showed you screenshots of it, but go watch it. It's only 30 seconds, and it's fantastic. thefifthofgaming.com, you can find my web app there, and the tutorial that I wrote for writing C# code for broadcasting Bitcoin Cash transactions, you can find that on read.cash using this link. And with that, I have reached the conclusion of my scheduled remarks. So let me, I guess I'll pass it over to Katie to facilitate the Q&A session.
For sure. And I will be getting the presentation from David. So I'll be getting that links page, and it'll be going on the Smart Data website on the blog. So if you went to the Smart Data website to register, it'll be that same page, but that'll be out on our LinkedIn as well. So if you're looking to get that, and when the recording goes up, it'll all be on that same page. Just scrolling through, I know we had a couple of questions, comments during, one from Tim. The Bitcoin.com application, is that wallet held by me or by them in my name?
No, yeah, oh, that is a fantastic question. So in the cryptocurrency world, there is a distinction between custodial and non-custodial solutions. So a custodial solution means the service that you're using, and I'll use Coinbase as an example. I love Coinbase. It's a fantastic service, but that is a custodial service. With the custodial service, they hold the coins. They hold the coins on your behalf, and you can ask them, like, hey, will you please send coins on my behalf to this address? And most of the time, that works fine. But I very much prefer, when we're talking about wallets, non-custodial solutions. So with the Bitcoin.com wallet, that is non-custodial. The private key for that wallet exists on your phone and nowhere else in the world. So the only person who is capable of moving the coins in your wallet is you. And that's really, in the purest sense of cryptocurrency, that's the way it should be.
Follow-up question from Mason is, can you back up this wallet, for example, if you lose your phone?
Yeah, absolutely. So if you go into settings, there's backup options, and what that will look like is they will give you a 12-word seed phrase. So write those 12 words down and keep it somewhere safe. If you ever lose your phone, or you get a new phone, whatever, just type those 12 seed words in, and it'll recreate the wallet from scratch with the coins still inside.
Yeah, there was a couple. I think looking in there, seeing there was a couple of options for how to get it in there. Just for a note for the audience who maybe wasn't gleaning chat, I think our winner today was Bob with the $8.45 as the highest claimed.
Yeah, there was I had one in there that was like $14.50 or something, and I didn't see anyone. No one's mentioned it, so
I didn't see it either. So if somebody did, and Real said he got the $21.
Oh, okay, nice.
Holding back on us. He didn't want us to know about his fortunes. I think that's all of the questions I saw. I think comment from Tim saying adoptions comes when it's easy to use, which you just showed with your app. I'm convinced and off to buy some Bitcoin now.
Yeah. No, okay, so two things to say about that. First of all, yeah, the ease of use factor has just taken giant leaps and bounds forward. My first Bitcoin wallet was Armory, and it was a giant hassle. Like, even I, computer scientist, master's degree, all that stuff, it was a huge hassle. I had to keep like the blockchain synced and everything, and it was ugly. And now I can get someone up and running in like 2 minutes and show them a receive and a send, and it's super easy. Yeah. Second thing I'll note, and you know, yeah, I'll be careful and be explicit here. When you say you want to go buy some Bitcoin now, Bitcoin and Bitcoin Cash are not the same thing, believe it or not. I actually had a segment in this presentation. When I originally made this presentation, the first draft was like 3 hours long, and I had to cut stuff out of it to fit in this time box. But I had a whole segment about Bitcoin and how it's like not useful anymore. It's very slow, very expensive. There was a split in 2017 where Bitcoin and Bitcoin Cash, they have the same history. They have the same genesis block, but 2017 they split off, and Bitcoin is now, in my very well-educated opinion, garbage. It is totally worthless. It's slow and expensive, and it's nothing's being built on it. It's just garbage. And then Bitcoin Cash went off to be the original vision of Satoshi Nakamoto as described in the white paper. And I'm going to jump in. I see a question came in about the Lightning Network. So again, the segment that I cut out included like, okay, here's an explanation of the Lightning Network, and here's how it works, and all that stuff. Unfortunately, I had to cut it out for time, but the answer to the question is no. The Lightning Network is very complicated. It is wildly overcomplicated in terms of what it's trying to do. Gavin Andresen actually once tweeted that the Lightning Network is more complicated than Bitcoin by at least an order of magnitude. There's also a lot of reasons why Lightning Network transactions can fail. So like if there's no chain of properly stated channels between you and your destination, it will fail. If your destination is offline, it will fail. If there's no path at all between you and your destination, it'll fail. Also, like, sorry, okay. I could go on for a long time about the Lightning Network, but let me just say the answer to the question is no, it doesn't really work. And actually, this is what I'll do. You can look at the bottom line. The proof is in the pudding, so to speak, with respect to the Lightning Network. So there is a very real demand to move Bitcoin. And we know there's a demand to move Bitcoin because the transaction fees are very expensive. They are routinely 4 or even 5 orders of magnitude higher than transactions for Bitcoin Cash. The Lightning Network ostensibly offers a solution to that problem. It offers a way to move Bitcoin in a not expensive way. Now, if it was good at doing what it claims to be able to do, people would be using it. But the Lightning Network has been live for years now, and the amount of coins that have been moved to the Lightning Network to facilitate these transactions is 0.007% of the Bitcoin. So like, nobody is using this thing. And again, I could go on about the complexities and the problems and not viable even on paper and all this stuff, but I don't want to get off too far on a tangent. Well, let's talk more afterwards if you're interested.
All right. I see Ben posted about Taproot.
So the Taproot upgrade, which just went live in Bitcoin this last week, a lot of people in the crypto space were all jazzed about it because like the misconception is that Taproot gives Bitcoin the ability to process more complex transactions. Like it effectively makes it a smart contracts platform. But I can say unequivocally that that's not the case. I will also say that Taproot is like they're way behind. Like lots of people have implemented this already, but I haven't bothered understanding the details of it for the Bitcoin chain. Like I barely pay attention to Bitcoin anymore because nothing's happening over there. Sorry, I don't have a better answer for you.
All right. I think that was the bulk of the questions. Does anybody else have any other questions? Looks like we have some calls for maybe round 2, round 3, round 4 of talking more and more about.
Yeah, hey,
Bitcoin.
I mean, November 2025, let's do blockchain 3.
So there was a question about maybe recommendation for keeping the momentum going. What is maybe your top recommendation? So
for me and my part, I'm always looking for opportunities to show this to people. So That takes several forms. Number one, every time I'm tipping somebody, I will offer a Bitcoin Cash. I had guys delivering my a table for my dining room a few weeks ago, and I said to them, like, hey, you guys take tips? We take cryptocurrency? And it turns out, like, well, I knew this already. I was just joking with him. It's the same moving group that was here a few months ago when I had tipped them with Bitcoin Cash then. So I have tipped my hair cutter lady. I've tipped the massage therapist lady. I've tipped the moving guys. I've tipped the pizza delivery guy. Like, people are excited to experience cryptocurrency. So I show them the app. I send them the money. I have them send me 5 cents back, and it's really easy. And the other thing is, like, you'd be surprised how often in life somebody needs to give you money for something. Like, oh, hey, we're splitting a pizza. I owe you $10 or whatever. I have a standing policy now where if someone owes me money for something, I will accept money that's made out of paper and backed by the full faith and credit of the US government, which means it's backed by nothing. I will accept that money, but the price, the cost to pay me in that is that you have to listen to me explain Bitcoin Cash, and you have to let me give you $5 of Bitcoin Cash before you pay me with your Monopoly money. So, and it's just sort of a general, like, I'm always looking for opportunities to use it. Every time I use it, I go buy more than what I use. So I gave away $100 in this presentation, and right after I did that, I went and bought $200 worth of Bitcoin Cash, just kind of refill my wallet and ready to go. But yeah, I think it's going to be a sort of a grassroots thing when it takes place. The United States is, in all seriousness, very fortunate in terms of its stability. There are places in the world where sound money, as problematic as the US dollar is, there are places in the world where sound money is a very real, very manifest problem. And my suspicion is that, the more people understand that this technology exists, the more people will just say, like, why are we using this government issued paper? Like, let's use sound money that no one controls, and it's really easy and it's free to use. And yeah. So, and yeah, Tim, you're right. Like, the value of the dollar it's decreasing. Like the, $7.25 for a minimum wage worker is worth less today than it was last week and the week before and the year before. And this just goes on and on forever. Like, the value of the dollar gets, asymptotically smaller every year. It's approaching zero. And when you're using a decentralized currency that no one controls, like, all of those problems just go away. I've reached the point where I don't care if the dollar becomes worth less and less, because I have real money that I can use for stuff. And my project now is introducing it to other people so that I have people to transact with. I'm like I'm the first guy in the neighborhood with a telephone, right? I have this super cool technology, and I don't have anyone to call, so I'm trying to.
On that, we're going to have to wrap it up because we hit our 1 o'clock. We need to get everybody back. Carla, I'm going to talk with David, and we'll get you your response back, maybe in a cool blog post about what happens when you pass away and what happens to your wallets. So
thanks so much, everyone.
We'll pull into that. So thank you, everybody. And we'll be, like I said, we'll be posting this online here as soon as we can. With the holiday next week, it might be a little bit later than usual, but thank you all so much for coming, and we'll see you at the next one.
Thanks, guys.
Thanks, David.
Thanks, David.